Okay, here are some hints for this calculating other angles, especially these application projects. For number 11, your line of sight are tangent to the circle on both sides, and the angle made by those tangents is a viewing angle. So I'll take this sphere example and I'll make it a little bigger, not to scale, and draw tangents to it that meet externally. This is your line of, sorry, that's not your line of sight, that's your viewing angle. So this type of picture is going to be used for all of them. If your viewing angle is 36 degrees, what is the arc of the object that you can see? So the arc that you can see, if you're pretend like you're out here, the hint is to draw a picture, and you're viewing, there's some binoculars, and you see this part of the sphere. It's an arc. What's that angle? So I thought a lot about this, and you could use that equation that the measure of angle 1 is 1/2 the difference between y minus x, if this was the picture. If this is arc y and this is arc x, here's angle 1. Or, watch this, and thank you, Mr. Wayne, for telling me about this one. It's always nice to be able to draw in radii, especially radii with tangents, because that makes a 90-degree angle. So you don't even need algebra on this one. You don't need to label the arc. You can remember that radii to tangents are 90 degrees. This has now made a quadrilateral. In fact, it's a kite that has two pairs of adjacent sides congruent. So, and if you have a quadrilateral that has three of the angles that you know, 90, 90, and that one's 36, you can find out this angle, here it is in red, and that angle is a central angle which has an equal corresponding arc, which is going to be the arc of the object you can see. Very, very similar to number 12. I didn't even have doesn't have the picture up here, but this is number 12. That's working backwards. If you can see a 104-degree arc, what's your viewing angle? Use that same diagram. This time you don't know what the viewing angle is, but you know that it's a 104-degree arc, which corresponds to a central angle of 104 degrees. Can you go from there? Hint, hint. Okay, number 13, this is definitely not going to be to scale, but you got a viewing angle of a satellite that's 12 degrees. And I'm going to try to draw a 12-degree, here's an Earth right here, and then a satellite is way, way out there that has just a tiny sliver. Again, not to scale, but, oh, the viewing angle of a satellite is 12%. So here's the satellite out here. There's its panels. And its viewing angle is 12%. Again, use the fact that you've got tangents drawn to the circle, make 90 degrees. You've got a kite or a quadrilateral, and opposite angles of those quadrilaterals are supplementary. Go with that one. Now I believe this number 14 is going to be quite similar. Let's get that Colosseum down here, and you want to capture a 165-degree arc. So that means you want of this Colosseum, which I think for this case you can assume is circular, but I'm not sure if it is circular. I think it's more elliptical. Anyway, pretend like it is circular. That the photographer wants to get a 165-degree arc. So that part right there needs to be 165. Out of the 360. With what we've done on 11, 12, and 13, I think you can work backwards to find out what the viewing angle will be.